at the sheet here, that is kind of going to be our little cheat sheet of what to expect on the test. We've gone over sig figs and we have gone over accuracy versus precision. So the next thing I want to talk about is density, because that's the next thing that we talked about in class. And when we're talking about density, I'm also going to be talking a little bit about dimensional analysis, which is where you're canceling things out. And that, personally, to me, is the easiest way to do any type of calculation in chemistry and physics and bio. Anything that has to do with changing numbers and doing calculations, dimensional analysis is the way that you want to go. Okay, so I'm going to do an example of dimensional analysis first. So dimensional, because this is why I'm a STEM major. I don't know how to spell, and spelling doesn't really matter in chemistry. So analysis, I think I spelled analysis right. Okay, cool. Dimensional analysis. Right, so let's say that we have 24 inches and we want to find out how many, let's say, kilometers that is, right? Okay, so we have 24 inches. So we always start with the number that is given, right? So we do the number that is given over 1. If you have something that's like 24 meters per second, you do 24 meters divided by seconds, right? Okay, so now in order to get to kilometers, you can do it many different ways. What I'm going to do is I'm going to go from inches to feet to meters to kilometers, right? That's just kind of like my game plan here, just because I know how many inches are in a foot, and then I can ask my Amazon device here, I don't want to say her name, how many feet are in a meter and how many kilometers are in a meter. I already know that. So this is the only thing I really have to like worry about. But anything like that, he's going to give us on the test. But the only thing he's not going to give us, I don't think he's going to give us this. I'm personally going to put this on my own sheet, on my like 3x5 index card. I'm going to put down the like King Henry died by drinking chocolate milk, that whole, metric system. That's what it's called. Okay, going on, right? So we start with what's given, and then we always want to cancel things out. So what's going to be on the bottom is inches, right? So we know that in 1 foot, there are 12 inches. Yay, we can cancel things out, but I'm going to do that at the very end. And this is when I have to ask my Amazon device, Alexa, how many feet in a meter? I think it's like 3.3.
1 meter is about 3 feet 4 inches.
Okay, so 3 feet 4 inches. So I'll just call it 3 point. How many? 4 divided by 12. This is just me doing my own thing. Okay, it is 3.33. All right, I should have known that. I did that in like first grade. Okay, feet, and then in 3.33 feet, there is 1 meter times. Now, we have to go from meters to kilometers, or kilometers, whatever you want to call it. I don't know. It's a British thing, so who knows. We know that in 1,000 meters, there is 1 kilometer. That's just something that I have memorized because I know that K means 1,000, and that's why we actually say, like, something's worth 2.4K. You're just multiplying it by 1,000. So yeah, that's just how I know that. That's why they do 1.4K. Like 2.4K means like 2.4 $. So yeah. Anyways, I literally just discovered that this year. You guys are probably watching this like, duh, Grace, like you didn't know that. But yeah, so now let's look and see if we canceled things. You guys can probably tell by all these videos that I like pink, so I'm gonna use pink. So inches and inches, gone. Thank God, don't want inches. We just want kilometers. All right, feet and feet, gone. Meters and meters, gone. And the thing that you want to also keep in mind is that you want the number that you want, or the value, whatever you call it, you want that to be on the top, right? So if you had something like meters per second that you wanted to end with, you want it to be meters divided by seconds towards the end once you cancel things out, right? But we're not dealing with that, so we're going to say we just want kilometers on the top because that's what we're shooting for. And we are going to put all of this into our calculator. So we're going to do 24 times 1/12 times 1/3.333 times 1/1,000. So the answer that we are going to get is 6 times 10 to the negative 4. That is our answer there for our dimensional analysis. Let me just ask my Amazon device to confirm that. Alexa, how many kilometers are in 24 inches?
24 inches is 0.0006 kilometers.
0.0006. 1, 2, 3, 4. Perfect. Yay, we got the right answer. Cool. So that's dimensional analysis. I just wanted to go over that because it's going to be brought up a lot, especially when you have to like change different numbers and everything and go from grams to kilograms or things like that, or kilograms to grams, right? Okay, so now what we're going to be talking about is density. Yay, density. So basically what density tells us is how closely packed are the molecules in something, right? So when we're talking about oil, it's very not dense because the molecules are pretty big. Water has a density of like 1 grams per milliliter, something like that. It's like 1.013. I don't think you have to memorize that, but personally, like, I just know that off the top of my head. But because oil is less dense than water, it floats to the top. If you ever tried to mix water and oil, I'm sure you guys did that before in lab or when you're cooking or something, you know that oil floats to the top because it is less dense. So that's basically what density is, but we are going to be talking about the calculations for density. So what density is that it is D divided by M, or M divided by B. Probably like, what does that all mean? So this is density, D is density, is equal to mass divided by volume. There's an M in there, Grace. Alright. I feel so bad that everybody's watching this. They're probably like, alright, stop talking. Just teach me how to do this. But I have to have some self-hatred humor in there. Okay, so the main thing that you want to be cautious with this is units. Oh. I'm getting a call. Okay. We're just gonna ignore that. Turn off my speaker. Okay, so the main thing that we want to worry about here is units, right? So if you're asked to put something in grams per milliliter, you better make sure that mass is in grams and volume is in milliliters, because that's what we're going to be getting, right? Yeah. So, let's do some examples on that. I'm going to do some like really quick examples because this should also be fairly easy. Alright, so let's say that we have 24.26 milligrams of gold. We love gold. And I'm going to look up the density of gold. Of golf. That's embarrassing. Grams per milliliter, 1.09. Really? Gold is like about as dense as interesting. Wait, I think I looked up golf ball. Okay, I was like, there's no way that it's okay. Density, okay, 19.32. Okay, we know that the density equals 19.32 grams per milliliter. At least I think they did it in grams per milliliter. Yes, okay, so also, just for reference, if you see centimeters cubed, it's the same thing as milliliters, or not cubed. Yeah, if you see centimeters cubed, it's the same thing as milliliters. So you'll see a measurement that's like 1.2 centimeters cubed, it's the same thing as 1.2 milliliters. That's just like volume, and centimeters cubed is equal to milliliters. Either way, so these are the values that were given, and we want to find volume of this thing, right? So we know that density is equal to mass divided by volume. This could be a practice question, so you guys can pause and try it yourself if you'd like to. So we're going to do 19.32 grams per milliliter is equal to, oh, would you look at that? This is in milligrams, so we have to do some dimensional analysis to fix that. Milligrams divided by 1 times, there are 1,000, no, there's not 1,000 milli. King Henry died by drinking chocolate milk. Oh, there is 1,000. Okay, so there's 1,000 milligrams in 1 gram. So this number will become, I'm going to move this over 1, 2, 3 times. Yep. And we'll get 0.024226 grams. Okay, so now we know that the mass is 0.02426 grams divided by volume. And you're pretty much just gonna do what you would do in Algebra 1 or 2. I don't remember what class it was, but it was a long time ago for me. So we're gonna do that. Alright, so you get that, and then we're gonna divide all of this by 19.32 grams per milliliter. 19.32 grams per milliliter. And we can cancel out grams. We also cancel out grams here. So what we're going to get is that the volume is equal to 0.0262 divided by 19.32. Wait, I did this wrong, didn't I? No, I didn't. Doubting myself. 1, 2. Oh, here it is. Sig figs. We're doing it, guys. We're doing the sig figs. Alright, we're given 4 sig figs and 4 sig figs, and we're doing multiplication / division, so we are going to be using the sig figs. Let's go. So we got 4 sig figs here, 4 sig figs here, so we're going to have is 4 sig figs at the end. So 5, and then this is going to become a 6 milliliters. Yeah. Cool. There's our answer. But yeah, so that's basically how you would do density. I think I'm going to end that video here because it should be decently easy. Just also keep in mind that if you're doing something that has to do with, like, oh, you put something in water, you know, let's say you have this, there's your beaker, here's your water, and then you add in this solid, and the water now goes to this level. The volume of that object is going to be the final, so the water final minus the water initial. And that'll give you the change in the volume of the water, which is equal to the volume of the solid. So just keep that in mind when you're doing your calculations. There might be one where it's like, you put this in this, and you have to find the density due to this. So yeah, just keep that in mind as you're going through these. Alright, thank you all for watching, and have a good one.